Okay, so this is the AMY problem. So normally the AMY problem is pretty hard, right? You can see it. So in this problem, you can see, let's find some patterns. It gives you three equations, okay? It's 1 times x1, 4 times x2, 9 times x3. Okay, it gives us some indication of like this is the 1 square, the 2 square, the 3 square, up to the 7 square, right? The coefficient. And the second equation just shifted. See, it's the 2 square to the 7 square than the 8 square, right? And the third equation is same thing, it's shifted. So this is the pattern. We can see something, the coefficients is n square, right? It's changing. Okay, but over these three equations, right, we can see the constant is x1, x2, 2, x7, right? Basically, it looks like it's unknown, but it's a constant over the three equations. So that's why, okay, so this is really, if you are just initially getting to know the math, the Olympic math problems, there is a common way we deal with it over the multiple thing. Problem is the unknown, but it's the same. We treat as the known. But even the known number, but they are changing, but they have a pattern, we change as the unknown. So basically, let's define a function. Okay, here the function is we use the n square of the x1 plus the n plus 1 square of the x2 plus blah 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 blah, then n plus the 6 of square of the x7. Okay, so now what do we have? We have the f1 equals 1, then f2 equals 12, and the f3 equals 123. The question is asking what? The question is asking us for what is f4 equals what? Okay, now see, we translate this problem into a pattern. Okay, now we can try to see how we can derive. Basically is what is the f4? Okay, is what kind of function if we know the f1, f2, and f3. We can solve this as 4. Okay, now let's see. Let's see using the general propagation. Okay, so fn plus 1 is n plus 1 square of the x1 plus n plus 2 square of the x2 plus blah 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 plus n plus 7 square of x7, right? So now you can see here, okay, we already know the n square of the x1, right? So let's expand it. Let's expand it is n square x1, right? This we already know. And there is a 2n of the, let's write it in this way. Okay, I will tell you later I write it in this way. Okay, and the 2x1, right? And the plus. So we already know the n plus 1 square of the x2, right? We want to have get the, this is the n plus 1 of the square of the x2 plus something. So this basically the first row is the fn. We want to get a fn, right? Getting something we already know. Okay, so that's why we do this one is the 2n 2n plus 1, so n plus 1 of the x2 plus the 2x2. Okay, then plus, let's see, this one is n plus 6 square of the x7, right? So see this one, So this section is exactly what we already know, is the Fn. Okay, then we have the plus the 2n plus 11 x7 plus 2x7. Okay, now this is the two terms, okay, we are trying to solve, right? So if you can see it clear, let's see it clearly, okay? If you can see, we already have the n equals 3. We want to solve x4, right? f4 is already equal to the f3, right? Plus, right? We have a row of the 2n minus 1 of the x1 plus blah 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 plus the 2n plus 11 of the x7, and then we still have another one is 2x1 blah 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 plus 2x7, right? As long as we solve all this, and we see this one is a function of the f1 or f2 and f3, right? And this one is another function of the f1 and f2 and f3. Now we solve the problem. Okay, now let's see how we can solve this. Okay, let's do the fn minus fn minus 1. Okay, so that's why this one equals what? This one equals the 2n minus 1 of the x1 plus 2n plus 1 of the x2 plus 2n plus 11 of the x7. Okay, now did you see here? Okay, so this one, okay, the second row, you can see it. Now let's how we can cancel this, right? Let's do the fn minus 1 minus fn minus 2 is equal to 2n minus 3 of the x1 plus 2n minus 1 of the x2 plus 2n plus 9 to the x7. Okay, now you can see we have this one 3 and 4. If we use the 3 minus 4, what do we have? We have the fn minus 2 fn minus 1 plus fn minus 2 equals 2 of the x1 plus blah 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 plus x7. So see, that's this one. Okay, so now we solve all the items we need to solve the f4, right? So f4 equals the f3, right? Okay, then plus, right? So it's the f3 minus f2 is this term, right? And the plus the f3 minus the 2f2 plus the f1 is the last term, is this. Okay? Then let's combine them together. So it will be 3 of the f3, okay, minus 3 of the f2 plus the f1. So the final answer is 3 times 123 minus 3 times 12 plus 1 is 334. Okay, so this is pretty hard problem. Is basically you need to see we treat the x1, x2, x7 as known, and we create another function changing as with the coefficients. So that's about of this problem.